Good morning. My name is Lyle Tavernier, and I'm speaking to you from NASA's Jet Propulsion Laboratory here in Southern California. Excited to talk with you today and have you join us as we learn about the Mars helicopter and take a hands-on approach to building our own. To talk a little bit more about what we're going to do during today's session, I'd like to introduce to you our very talented co-host, Brandon Rodriguez.
Hi everyone, my name is Brandon Rodriguez. I work with Lyle in the education office at JPL. Really excited to work with you guys today. Today we're going to be building a paper Mars helicopter, our own little version of Ingenuity, which has been gone through several test flights on Mars so far. A really exciting time and the proof of concept of a really crazy new technology. This lesson can be found on the JPL education website, where you guys will find many activities just like this that you guys can do on your own, that your teachers can lead in classrooms, and one of many opportunities to engineer your own way to kind of explore space, just like we do here at JPL. So Lyle, tell us a little bit about the Ingenuity helicopter.
Sure thing. So the Ingenuity helicopter, as you mentioned, is a new technology. It's a demonstration to really prove whether or not flying on another planet was something that we were able to do. So first thing I want to do is show you a picture of the Ingenuity helicopter on the surface of Mars. Now this was taken by the Perseverance rover. The Perseverance rover is the, let me see if I can bring that back up. I wanted to let you see it for a little bit longer. There we go. The Perseverance rover is the vehicle that brought the helicopter to Mars, and it lowered it down on the surface and took this shot of it so that we could see that it was actually there on the surface of Mars. And then from there, we needed to begin our flying. Now, flying on Mars is a little different than flying here on Earth. There are a number of challenges that we have to consider that are a little bit different from flying here on Earth. So one of the things that we have to think about is the thin atmosphere of Mars. Now, if I go like this, and you can do this too, you can feel the atmosphere hitting your face. It's literally what you're feeling, is the atmosphere hitting your face. Now, on Mars, the atmosphere is about 1% as thick as our atmosphere. So if you did this on Mars, you'd probably have a spacesuit on. But if you could do this on Mars without a spacesuit, you wouldn't really feel much. That atmosphere is what provides the lift here on Earth, and it's also what provides the lift on Mars. And so in order to make enough lift with that thin atmosphere, we needed to have a helicopter that would spin its blades very fast. We also had to make the helicopter very light, because even though the gravity on Mars is lower than the gravity here on Earth, we had not as much lift generated by the very fast spinning blades because of that thin atmosphere. So again, thin atmosphere, very lightweight vehicle that we had to build. It only weighs a couple of pounds, which is kind of incredible when you think about a spaceship only weighing a few pounds that we sent to another planet. And then we had to make sure that it could survive for the trip to Mars, but also the very cold temperatures. Once it was released from the rover, it had to survive on its own. That means it had to have solar panels that could charge up, the batteries to keep it warm. We had to make sure the electronics inside didn't get too cold, because Mars can be very cold, hundreds of degrees below zero overnight. And so one of the first things we did after we set it down is the next day we had to make sure that it was still alive and operational. So a very cool mission. And what I want to do, because it's such, this is one of my favorite pictures here that I'm going to show you. This is a selfie taken by the Perseverance rover after it set the helicopter down on the ground. So this is pretty cool. Excuse me. And it sort of sets the stage for where the helicopter is going to take off from for its first flight. This was a place that we named Wright Brothers Field as an honor for the Wright brothers' first flight in Kitty Hawk over 100 years ago. And what I want to do is just very quickly show you, and then we'll get into the build and start answering some of your questions, the first flight of the Ingenuity helicopter. So let me get it going here. If you look closely at this picture, this is a picture taken from Perseverance. After Perseverance set the rover down, it drove far away from the helicopter. If there were any problems, we didn't want the helicopter to accidentally damage the rover. So we drove far away, took this image, and you can see very small down in the bottom center of the screen the helicopter. So as I hit play, you'll see the blades start to spin up, There it goes. And in just a few minutes, or a few seconds I should say, it's going to have enough lift to fly up off the ground. There it goes. And the first test was really, can we get up into the air? Can we do a little turn? And can we gently land back down on the surface? And here we come back down gently to the surface. I guess it's up there a little longer than I thought it was. There it goes back down to the surface. All right, so pretty amazing first flight on another planet. And so what we're going to do today, and I'm going to turn it over to Brandon for this, is we're going to build a helicopter here with just some supplies that you might have at home. So Brandon, do you want to talk a little bit about what we need and what we're going to do?
Yeah, absolutely. So as you saw from Lyle, the demonstration of this technology is really incredible. And how we're going to kind of model this today is actually really simple. We want to start with the basics and just kind of understand some of the fundamentals of what it means to build a helicopter that can land safely and explore new areas. So we're going to begin just by printing out a little template. This can be found on the JPL Education website for the activity we're doing today. And as you can see on this template, there's actually two templates for the helicopter. So maybe you're going to start with one and then maybe learn a few lessons about what makes a successful helicopter. And then at a later time, you can try the second one and make any revisions, any changes you like to make an even better one. So I'll begin first by just cutting out one section of the helicopter, and we'll kind of have our base model to begin with.
Now, as Brandon is cutting those out, what I want to do is I want to show you a picture, a little close-up of the helicopter to give you a sense of what we are looking at here when we're talking about different parts of the helicopter. So I mentioned a solar panel. That's that rectangular piece that you see at the top. And then below that, you can see one of the helicopter blades coming towards the camera. Now, what's neat about the Ingenuity helicopter is that it actually has twin blades. So if you think of a helicopter with two blades coming out from the side, the Ingenuity helicopter has two blades coming out from the side, and then right below that, another set of two blades coming out from the side. And the reason that we have two blades like that has to do with Newton's law. So if you've heard of the law that says for every action there is an equal and opposite reaction, if we had one blade spinning this way, the entire helicopter body would spin in the opposite direction. And we didn't want to have a spinning helicopter body. So by having blades that go in opposite directions, they counter that force out, and we can generate lift and have a stable body of the helicopter as it flies. So Brandon, looks like you've got your pieces cut out. Let's take another step here.
Yeah, so I've got my two helicopter templates ready. I'm going to put one off to the side for later. I've got now this body here. You see it's got an A and a B on the top. And you'll notice there are some dashed lines and some solid lines. So today I'm only going to be cutting on my dashed lines to get started. And I'm going to make my first cut here in between A and B. And when I do that, these guys are going to kind of serve as the blades on the top of my helicopter that Lyle just mentioned. So what you can do is fold these over kind of along this line here. But again, feel free to be creative. Maybe you want a little bit more arc or angle on your folds, but you're going to fold them kind of against each other. So one goes this way, one goes this way, and then at the top I've kind of got like a T shape. All right, so I've made a little T shape with the A and B folds going opposite directions on the top here. Once I have that done, I'm going to cut on the dashed lines here above X and Y. So let's make two more little cuts here. Again, I'm not cutting on the solid lines, just on the dashed lines.
Now, while Brandon is cutting out those dashed lines, one of the things I want to point out is this is version 1 of the helicopter that we are building. And to make the point clear, the helicopter that's on Mars was not the first version of the helicopter that we built. It took many years of building and testing and refining the design and improving it when we learned about changes that needed to be made. In fact, what I want to do is show you an early test of the helicopter. If you take a look at this video here, you can see this is one of the very early tests of the helicopter. We were trying to pilot it manually in a Mars-like environment, and you can see that it's tough to control a helicopter in a space like this. The helicopter bounces around a lot. It's moving back and forth a lot. It's not a very stable flight, and so we really needed to improve the design and change the way that we were going to fly this helicopter. And so, Brandon, when we're building this, we're starting with design 1, and we're probably going to make some changes.
Yeah, absolutely. Your first one is never the best one. So there's so many chances to, again, have a second one ready, make some adaptations, some changes to the one we're going to play with, or print out more and keep going. So kind of looking where we left off, we've got our T on top. I cut the X and Y slits here, and I'm just going to fold them in like so that I've got a second T shape. Our helicopter here is kind of like two T's, right? So I got the T here, I got the T on top. So just one more time. My A and B go opposite each other. They're my little propellers on the top. And then X and Y get folded in like so. And this gives me my body of my helicopter. My last step then is just, you notice maybe there's a little Z down at the bottom. And I'm just going to fold that there upward like so. And voila, we've got a beautiful helicopter.
Very nice, Brandon. Mine actually looks similar. I've been building along. When Brandon was on camera, I'd be working with mine. And I've got a question for you, Brandon. When you folded yours, I folded mine so that the letter B is on top. Is your letter B on top, or is your letter A on top?
Oh, I got B on top.
Oh, interesting. Okay, so we've got matching letters on top. I'm curious if that's going to mean anything. If you're doing this along with us in class or at home, check to see if you've got B or A on top. Doesn't matter. Just something to make note of, and consider whether or not that's something you want to keep in future design changes. So not anything to change. You don't have to copy us. In fact, if you've got A, I'm super curious about what it's going to do that might be different from ours. So Brandon, are we ready to test, or we got a little bit more to do?
Yeah, let's do it. I think we're about set. And as Lyle has mentioned now, like, this is just the first test, and I can already think of, just hearing Lyle talk about the propellers on top, some changes I want to make after this one. So we'll kind of make some observations as we do our first drop, and then we'll maybe give some changes a try too. So you can imagine, I'm just going to try this from my desk, but if you have a staircase or a balcony or anything like that you want to try it off of, carefully stand on a chair if you like. You can get a little bit more height and have some more time to observe. But just as kind of our first flight, I'll give this a drop. Oh, not bad, not bad. Kind of a nice gentle landing. I saw the spin. It felt slow, I was surprised at how slow it went on its first rotation. Yeah, like I said, I can think of some things I want to change. What about you, Lyle? You want to try yours?
Yeah, I do want to try mine. I'm going to step over here so that you can kind of see a little bit better. But I'm going to give you two different angles. I'm going to give you my drop it from here, and then I'm going to give you an overhead angle. And part of the reason I want to give you an overhead angle is because of this picture right here, which I absolutely love. This is actually the first picture taken by the helicopter, so it's got a camera on its belly. And this is the shadow of the helicopter during its first flight, which I just think is pretty amazing. And you can see those twin counter-rotating blades because this was a quick snapshot. You can see the shadow of the blades instead of the blur of the spinning blades. But I'll give you an overhead view so that you can see that as well. But I'm going to do the same. I'm going to drop it from here. And you can see it actually took a little while before it started spinning, and that's why the overhead view is pretty nice here. So let me give you my overhead view. And I did it in slow motion. And when we're doing this, check a couple of things. Look to see what direction it's spinning, and see if you can maybe count how many times it's spinning. Now, if you don't have a slow-mo overhead camera, your family, if they've got a mobile device or a cell phone, they might have a slow-mo camera on there that you can do this as well. So take a look at my count here. So let's get it to drop. There we go. I'm counting 1, 2, 3, 4, 5 rotations before it falls. So not too bad. I really like that slow-mo look because I can really count. If you don't have a way to do a slow motion recording, you can actually take maybe a piece of ribbon if you've got some ribbon. I don't have any ribbon, but I have some sewing measuring tape, and that kind of works as well. You can straighten it out, step on it so it stays straight, and tape it to the bottom, and when you let go, the twisting of the helicopter will actually twist up that, that ribbon, and you can count how many twists there are and see how many. So I'm going to remember 5 rotations on mine. So Brandon, what are you thinking about any changes to your helicopter?
Yeah, I want to be a good scientist here, so I only want to change one thing at a time, even though I have so many ideas for other things to try. As Lyle was talking about how many rotations he was able to get, I thought, well, what if I changed the weight of my helicopter? So I've got this little portion on the bottom, right, where we had our Z fold, and I'm thinking now I'm going to add a paper clip to the bottom of it just to kind of make my helicopter a little heavier. And that gives me one variable that I can change to see, oh, does it spin faster? Maybe it starts spinning faster. As Lyle mentioned, it looked like it took a second before it got started. I'm not sure. So that was my first guess. I'll give that a little try now too. Ooh, much faster on the drop, and it looked like it was spinning more that time to me. Hard for me to count without the camera, but again, as Lyle mentioned, you could record these and have the opportunity to kind of capture your scientific data. What about you, Lyle? You going to try a second one?
Yeah, so I actually modified mine while I was off camera and you were dropping yours. I actually shortened my propeller blade. So you can see here as I hold it up to the camera, I cut about, I'd say that's about an inch off of each blade to see if that's going to change anything. And again, that's the only change I made. I didn't want to make 5 different changes because if I made 5 different changes and things got worse, I wouldn't know what made it worse. Or if things got better, I wouldn't know why it got better. I don't have my slow-mo overhead cam for this one, but I'm going to drop it. Now you'll have to take my word as to whether or not it's spinning faster or slower or more rotations. But here we go. So absolutely more rotations. I couldn't count how many, but just looking at it, it was spinning quite a bit faster, which was interesting. I'm probably going to have to set up my slow-mo camera for this one again and see if I can get that count for how many that was. So interesting that different changes will result in different performance. And as an example of that, what I want to do is I want to show you another video. So again, we've talked about how the helicopter on Mars is not the helicopter that we started with. Lots and lots of design changes. So the video that I am about to show you is, in fact, I can get it going here. Nope, that's Brandon. Let me bring up the video. Here we go. So here's the helicopter. You can see it looks quite a bit different. It's got the solar panel. This is an engineering model, very much like the one that is going to Mars. And unlike the first video that you saw that had someone trying to control it manual, we're using computers to control the helicopter in flight rather than trying to have someone control it with their reaction. The computer is just so much faster and able to control the flight. And you can see a much steadier flight. You can see some of the different things happening during this flight. You've got the spin up to about 20, looks like right around 2,300 RPM. So very, very fast. Climbing up to about 1 meter. This is really a lot like what happened in that test flight that you saw. Doing a little rotation, hovering, and then returning back down to the ground. So again, lots and lots of changes. This was a big project with lots of people who worked on it to make it happen. So you might make one change to your helicopter. You might make a lot of different changes to your helicopter, depending on what you're trying to do. So Brandon, do we have any questions about helicopters that people might be wondering about?
Yeah, we have so many questions, and actually, a bunch of students have actually submitted some of the changes they made. So
Oh,
someone
cool.
mentioned that they put a penny in the fold here to add mass, which is a really great idea. That's really, really smart. So yeah, countless adaptations that you guys can make to make your helicopter a little bit better. So Lyle, maybe you can take the first question, which is you just were talking about how we don't fly the helicopter with a person anymore. So we have a couple people asking, how does it fly? And you mentioned kind of coding. So is coding something that's important for Ingenuity and for the rover? And how can coding help students?
That is a fantastic question. Absolutely, coding is important, not just for Ingenuity, not just for the rover Perseverance. For all of our missions, coding, computer programming is incredibly important. And not just for the design and operation, but even for the analysis or the study of the data that comes back from these missions. Being able to look at lots and lots of data and write some computer codes to look for patterns and things like that is really important. Now, when we operate the rover and when we operate the helicopter, again, the helicopter is really hard to fly manually with a joystick right here on Earth. But also, the distance between Earth and Mars is really far, millions and millions of miles. When Earth and Mars are close together on the same side of the sun, it can take up to 5 minutes for a signal at the speed of light to get to Mars. So imagine trying to control a helicopter. You tell it to turn left, and you wait for 5 minutes, and then the helicopter finally turns left. But you don't see that it turns left for another 5 minutes. It's just impossible to do that. And so what we do is we have a team of operation engineers who set up a list of commands for the helicopter to do. We send those commands to the rover. The rover then relays those commands to the helicopter, and then the helicopter is able to carry out those commands as it's supposed to. Same goes for the rover. We send a list of commands for the rover to do. The rover wakes up in the morning on Mars and carries out those commands and sends us a report to let us know that it's done those things, or if it ran into a problem, that it ran into a problem and waits for further instructions. Now, all of those things are made possible because there are computer programmers here on Earth that are programming the helicopter, that are programming the rover to be able to send and receive those signals, and then to be able to read those commands and understand what to do. So yeah, absolutely, computer programming is very important. And if you are not familiar with computer programming and you want to kind of get a start, there's a fun activity. I'll put this URL up on the website. If you go to this website here, there's an activity where you can use a visual programming language and create a Mars helicopter game. And it's fun. You get to create a helicopter game that does exactly what the rover on what the helicopter on Mars does. It flies, it moves to a target landing site, and I have a lot of fun. I actually make different versions of this game quite a bit and then play it and see how I do. So yeah, coding absolutely a very important thing for this mission, but in general at NASA. And if you just want to have some fun and challenge yourself, it's a cool thing to try to learn.
Yeah, Lyle and I are going to be very busy today trying our different coding and recording our different helicopters now with all these great ideas. Another student was asking, how long did it take to build this helicopter? And when you look at all of these videos, you can see that this was, just like our helicopters today, not done on the first try. I was kind of laughing, recently we had a guest speaker where you can find that recording on our Teaching Space website talking about the helicopter, where she said she had only worked on the helicopter for 6 years, even though it took 8 years to make. So this really took a long time, a lot of crazy ideas being tried and discarded and then edited and trying again. Because this is such a new idea. This has never been done before. Nothing like this has been done before. So when you start from scratch and you're kind of really trying something crazy, it can take a really, really long time to get it right. But imagine how exciting it must have felt for these scientists and engineers to see that first flight, to see the images that Lyle has been showing you today.
Yeah, in fact, you can actually go online and see the video of that first flight when the data comes back. And yeah, absolutely cheering, jumping up and down. Yeah, absolutely. Brandon is 100% correct there. Other questions, Brandon?
Yeah, one that I really liked that kind of draws upon some of the fundamentals that we're learning about today. Could we potentially make a helicopter or a quadcopter or something like that that could work on another planet other than Mars? And what kind of considerations would we have to consider?
So I like that question because there is a really good answer, and that's a mission called Dragonfly. And Dragonfly is a mission that's being designed that will be a quadcopter going to the moon of Titan, which is a moon of Saturn. Now, Titan is sort of the opposite of Mars in terms of atmosphere. Titan has a very, very thick atmosphere, and therefore those rotating blades will be able to generate a lot of lift without having to maybe go quite as fast as the helicopter on Mars. And also, we won't have to be as constrained or limited by the amount of mass that we can put on it, because we're not trying to, I should rephrase that, because we have the ability to lift more on that moon because of its thick atmosphere. So I'm excited for that mission. There will be changes for sure. It's not going to be the same design. It's a different team, but I think there are a lot of lessons that can be learned from this technology demonstration that we can then apply to something like Dragonfly, or if we were to send a helicopter or a rotorcraft mission to another place in the solar system. All of these lessons that we're learning can be applied to that sort of mission as well. So yeah, absolutely. Technology demonstrations are a great way to prove that something is possible. And a good example of that is the technology demonstration we did in 1997. It was the Sojourner rover. It was only about this big, and it proved we could drive a rover on Mars. And now we are up to, what are we at? Our 5th rover on Mars. And so we have had very good successes because of that technology demonstration. So great question. Good thinking.
Yeah, and as maybe the last question to close us out, in a similar vein, several people have asked, are there plans to build future helicopters or kind of flying spacecraft? And the answer is, seems like yes, why not? Like this has been a really, really successful demonstration. And you can imagine that if there were kind of a helicopter accompanying a rover, you could have this kind of scout, this kind of ability to get a more detailed view of where the rover should go. And making these little hops up ahead of the rover could potentially say, oh, look over here, there's something to go explore, or this terrain's a little treacherous and maybe you don't want to head this way. So it really does open up a pretty exciting future for what scientific exploration on other planets could be. And I think it's pretty exciting. So Lyle, we're about out of time. Do you want to close us out?
Yeah, I just wanted to say thanks for joining us today. Brandon and I love talking about this sort of stuff, but I do kind of want to point out that really the Mars helicopter is the result of a huge team of people. This picture right here is not everyone who worked on the team, but it is an example of just the fact that something like a Mars helicopter is more than just the few people you might see in the operations room getting the data back. It's many people working for years and years to accomplish these sorts of things. So I want to encourage you to do this lesson if you haven't done it. If you're just watching and you want to check it out, go to the website. You can download that PDF. If you don't have a printer to print out, maybe put a piece of paper up to the screen and trace it gently so you don't ruin the screen. But that's a great way to kind of get the outline of the helicopter. Or even just come up with your own design. See if there's a way that you think maybe there could be a different design than what we've provided that would be better. So that's all I've got, Brandon. I don't know if you wanted to close out with any last words.
No, just thank you guys so much for joining. I hope you guys are excited as we are for a really incredible year in Mars exploration, and we hope to see you again soon.